Hello, and welcome to the Health GoLIVE Webinar series. Today's episode is brought to you by your friends at Care Evolution. We would like to remind you that the Q&A feature is available, so feel free to send in your questions throughout the discussion. And with that, I will turn it over to our speakers.
Hello, everybody. I'm very glad to be with you. Thank you to everybody at Health and Vibe. I want to start out with that. I'm just going to have a thank you to everybody for giving us this opportunity to kind of discuss some of the things that we're interested in, and hopefully give an opportunity for everyone to ask some questions, get a little bit of an insight, and hopefully leave you with a good feeling of that's pretty cool. I think that's the thing that I came away from this conversation with Dr. Burke. So hopefully, and again, any questions that you have, please feel free to add them into the chat or into the question and answer box. Without any further ado, Dr. Burke, would you want to introduce yourself?
Sure. Hello, everybody. So I'm an MD by training, though started my career as a software engineer in health IT. I did a business residency of sorts at the Boston Consulting Group, and then was at a number of startups in primary care, population health, and home health. And now I'm excited to have come full circle back to health IT for the past few years at Care Evolution. I'm a clinical informaticist, essentially.
Awesome. And a little bit about myself. I come from kind of the other side of the table. So I'm a clinician. So I'm an emergency physician by training. Started out in Detroit, then practiced, and I learned kind of at the bedside a little bit about how to take care of patients, but also then kind of learning some of the issues, not only with taking care of the patients directly, but then kind of the issues around healthcare that influence how we take care of people. And that kind of led me to go learn a little bit more about the systems in emergency care, and kind of learned all about these really cool people that do public health that kind of strive for that. So I spent a little time there before coming back to Detroit to kind of practice and try to implement some of those changes and learn more about systems and more about how they break. And some of that led me to try to want to put patients back into the middle of everything, which eventually brought me over to Care Evolution from kind of the clinical innovation side. So that's how Dr. Burke and I got to know each other. And it was very exciting to kind of talk and kind of see each other's perspectives. One of the things that we were chatting about that kind of started this conversation was kind of how much has changed from like when we first started getting into healthcare. So it started out with like, when I was in AI, like, in medical school, you were like the lowest of the bottom rung, and your job was to kind of round on patients and pre-round, because while we had health records, the health records were only for us. They were the things that we made. And if we wanted to even talk to other teams, those were written like paper and pencil, literally, into somebody's physical paper chart that's sitting in their nurse's station. Like we kind of built the system around that, and even rounded later in the day, hoping that like the consultants would round first so we can go later. The information just was like, we needed it, but we didn't have it. And it's changed a lot. Dr. Burke,
yeah, when I was in med school, everything was on paper, essentially, except for work at the VA, because they had the Vista system. But that all really started changing in 2009 with the HITECH Act and meaningful use. There was a huge acceleration in digitization of healthcare. And today we almost take it for granted that every doctor's office has an electronic medical record, and that unfortunately sometimes they spend too much time sitting at the keyboard, but at least that the data is all digitized. But we also then found having systems talk to each other wasn't very straightforward, and that though HITECH and meaningful use had tried to push towards interoperability, it wasn't successful. And so it wasn't until 2016 with the Cures Act, which introduced both the information blocking rule that basically says patients should have access to their data, and put in place a number of steps to move towards interoperability, including adopting a set of standards. And so it's a very exciting time in health IT, because now we are finally at a point where there is a wealth of information. And the key really is, are we going to be able to make value out of it?
Absolutely. Yeah. And So one of the things that early in our conversation was, as a clinician, I dealt a lot with healthcare information, but more of like the front end of like, I just, I open the chart, I click the box, it's got all the things there. But if I were to have to explain to somebody how it's saved, or, and I know that it's difficult for health records to communicate across different systems, but if you asked me to explain why that is, I don't know if I could. And that was something that, go ahead.
Yeah, absolutely. And we face that all the time when, whenever we're asking often an analyst or an application developer to put something together for us, just use this data point. And the answer usually is, oh, well, it's not that simple. So let me give a bit of an overview of why that is. So are you able to see my screen?
Yep.
Great. So here's the main reason, right? We've got multiple sources of data. So even if you're in a position, whether you're at a provider or a payer or a research organization or even public health, you may have a wealth of data from a variety of sources, but it's likely in a number of formats, whether that's FHIR or CCDA documents coming in HL7 messages. But we don't need documents and HL7 messages and X12 messages. What we need is something like to answer a clinical question. How many vaccinated patients do I have that have in my panel that have had COVID-19, right? So we're really seeking to answer a question, and it's not that we need multiple sources of data to answer this question. We need first our data in a single common format. So we don't need documents and messages. We need encounters and conditions and labs, right, that we can actually ask questions of. This is a bit easier said than done, because taking all of these formats to get into a single common format requires us to map fields, and it's not typically just one-to-one, where it's very obvious what field in one format goes to another. We often have one-to-many mappings, many-to-many, many-to-one. So as a specific example, let's say we have an encounter code in a CCDA document. In CCDA, that can have multiple code translations. So you may actually have 5, 6, or more codes representing this encounter code. But in FHIR, there is one spot for encounter class code. So when we're thinking about converting this format, we need to make a decision of how are we going to actually do that. We also need to deal with the meaning of the data we're seeing, or the authority. Should we trust a data? So as an example here, say we had a patient who came in on January 1st, 2022, and let's say that they were diagnosed with diabetes 10 years ago, right? So maybe the CCDA document that their Epic system exports has a problem.effective date, but what is Epic putting there? Are they going to put in January 1st, 2022, the date of the encounter? Are they going to put in May 8th, 2012, the date, when the patient was diagnosed? Are they going to have the field blank, which is also a possibility? And so from the data we do see in this document, in FHIR, do we put the date we see in onset date? Do we put it in recorded date? Do we put it in the date of the encounter? So we need to deal with that. And it's often not even as simple as solving this once. There's variability across different formats, across different implementations of the same format. So Epic's implementation of HL7 v2 or CCDA might be different than Cerner's or Athena's. And furthermore, even if that were all the same, Jeff, as you know, at the point of care, there's going to be variation in how clinicians are going to use these systems. And so maybe at one hospital, or even one clinician puts something in field A, and at a different hospital or even a different clinician, they're putting that in some other different place. And we have to deal with that variability, including over time. And so there's a number of things that if we had a system to reliably convert data formats, we would want that system to have experience across a wide range of these formats, be able to monitor continuously, and have continuous improvement, since this is changing all the time. And really importantly, to be able to maintain provenance and traceability, right? So if we've got data now in format B, we want to be able to look back to where it came from in format A, so that we have trust in our data pipeline. So those are a number of the considerations which make it difficult, but that we should also be thinking about to have such a system.
Yeah, no, and that helps a lot to kind of understand, especially that example you gave with kind of the date. Like, are you talking about when it was actually entered or when it was diagnosed? I can see how a small amount of ambiguity can turn into something really confusing and just kind of compile on each other. Yeah, that's interesting. So, okay, and so I'm seeing that basically one of the initial problems that you have is even just like there are tons of different file types that kind of like to simplify, like an Excel document or a Word document or something like that. They don't all, they need to be read by in the same set of rules. It's the same type of file.
That's right.
Is that right? Okay.
That's exactly right. And the challenge, though, is even if we had a perfect system for converting, and let's say we've solved the conversion problem, so now we have encounters and conditions and labs and procedures. Well, to answer our clinical question, we need to go one level deeper, because in those conditions and labs and procedures, we still have a mix of well-coded data, which means data that has like an ICD-10 code or a SNOMED code, right? From a reference terminology that we can say, we know what this thing means. We may have poorly coded data, and I'll give you an example of that. Plenty of proprietary codes, right? So a lot of the EMRs have internal codes, and sometimes that's what makes it out into the data that is exported. And then plenty of time we have free text. We have what the clinician actually typed, actually put out in the export field. So in order to get from this mixed coded, uncoded data to answer the question, we might say, well, can't we just look at the reference codes, right? So for example, with COVID, WHO said use U07.1, which is an ICD-10 code, use that for COVID. Well, the challenge is if we look at that, we're probably only identifying a small portion of our population that actually had a confirmed COVID diagnosis. So we're going to be missing out. We're going to be incredibly underrepresenting the population that we're looking for. So we might say, okay, we won't use the code. We're going to look at the text, right? The display, the name that's in along with the condition.
Okay.
We could do that. But the challenge is we can do things like look at, okay, let's look for terms like COVID and SARS-CoV-2, 2019 coronavirus. So you can see we start to get into dealing with variations on how things are written. But then we may also need to deal with exclusion. So we might look for coronavirus, but we need to recognize that human coronavirus was the cause of the first SARS epidemic 20 years ago, right? We don't want that. We want to exclude that. And we also want to exclude cases where next to the condition it says rule out or not detected, right? Because those aren't going to count. We wouldn't want those to count as our history of a COVID diagnosis. So maybe we're getting a much bigger circle here, but now we've introduced probably a decent amount of this circle that is actually outside the bounds of the cohort we're looking to identify.
I got it. Okay. Now, but you're talking about like plain text. So, we kind of went over like how these kind of get mapped to codes in some way. And I know from my clinical experience is that like I can't move forward in some EHRs without actually like making a diagnosis. I don't want to put you on the spot, but like feel free to, if you don't, but like how is it that you wind up getting like free text out of some of these codes that like if I'm clicking through them?
Well, one, there is variation across systems, and some systems don't require clinicians to actually code certain things. But second is sometimes those things are coded, but somehow the codes don't actually end up in the export. So it's just the text that ends up out. Sometimes they're coded with an internal code, which is then mapped somewhere else, like maybe in the billing system, to the reference codes, because then it needs to be put on a claim, right, to send to the insurance company or to CMS for billing. But then when that EMR exports the data to a system looking to do research or to another system that is aggregating a longitudinal medical record, that conversion to the reference standard codes wasn't done in that system, right? It was done somewhere else. And so it doesn't make its way out. So while we do see plenty of well-coded data, there's still plenty that is not. And we need to deal with the free text.
I see. Okay.
So what we're really trying to do here is maximize our sensitivity, right? Which means try to fill as much of this circle as we can while maintaining specificity. So try not to include folks that are outside the circle. So we need a system for continuously improving and robustly standardizing our terminology. We need to map conditions to things like SNOMED and ICD-10, labs to LOINC, et cetera. Why is this hard? So standardization is difficult for a number of reasons. So one, there's a huge amount of variability in the way source systems give you even real valid codes. So E11.9, which is for type 2 diabetes without complications, maybe they left out the dot, maybe they made it a space, maybe they, some reason, added a bunch of additional text in the same field afterwards, right? So we need to be able to deal with that, whether the hyphen was included or not for a lab. There's also, when we're looking at the text, a bunch of domain-specific knowledge. So we might have DM2 without complications. We need to be able to take those acronyms and know what they mean. Is the 2 a 2 or is it a Roman numeral, right? Again, there may be additional text like a date or other kinds of things that's added onto here that we need to either deal with or ignore, et cetera.
Yeah.
There can be modifiers. So, we mentioned rule out. There's could be things like, this is a new onset, or this is with or without some complication. This is a final result, it's pending, right? These are things that we see show up all the time. And if we only look for the text DM2 or only look for HbA1c, we're going to miss out on the fact that, well, actually, it may be exactly the opposite of confirmed diagnosis or that this lab test was done. We sometimes need to deal with multiplicity in the text. So it may be a field where it has something like hypertension in DM2, and maybe that's great, and we're mapping to SNOMED, and there actually is a SNOMED code for hypertension and diabetes, but maybe it's even a longer list or some other combination of diagnoses for which there actually is no code or no single code in the reference terminology we're mapping to. So we need to make a decision. Can we map to multiple things? Are we going to just choose one? Which one do we choose? Do we map to nothing in this case? There are differences in terms, I think this gets a little overwhelming. Differences in terms of level of specificity. So let's say we have diabetes with chronic kidney disease. Well, maybe we, in our target reference system, we can map that to type 2 diabetes with chronic kidney disease. That'd be great. But it might be that our reference system is a bit less specified, and we could just as accurately map to type 2 diabetes with complications, right? Just more generalized, not specific about which complication. Or maybe we can get even more specific, although we don't have the data here to support it. Stage 3 chronic kidney disease, and they're on insulin, right? So we need to be careful when we're taking this source term and deciding which reference term to map to, that we're not over or under specifying based on the data we have.
Yeah, I can see how that can, get complicated.
Well, and it becomes even more complicated when, again, this changes over time. So every one of these reference code systems, whether it's monthly or quarterly, come out with new codes, they delete codes, they change the meaning of codes, right? And so if you've got a system that is in place for standardizing this stuff, it needs to be constantly updated so you don't end up with bad mappings, right? Which is, don't want to be sacrificing specificity for sensitivity, and you need to have experience over a wide range of data, because data from one system, maybe you've optimized sensitivity and specificity of your mappings there, but as soon as you bring on data from another new system, your balance may be thrown off, and so you need to be continuously monitoring and adapting.
Interesting.
So let's say we now have converted and standardized our data. Do we now have what we need to answer our clinical question? Well, kind of, because almost, we're getting there, we're very close, but what we actually have is a list of reference codes now, right? And so there is no one code for confirmed COVID-19 diagnosis in SNOMED, there's many codes. There's a disease caused by SARS-CoV-2. There's pneumonia caused by SARS-CoV-2. There's infection of the upper respiratory tract caused by SARS-CoV-2. And if we are asking the clinical question that needs us to identify confirmed COVID diagnosis, we want to include all these things. And we certainly could list out all the codes we want to include. But again, if we have to do this for many different conditions, if we need to maintain this over time, it would be great if we had a system that allowed us to take conditions and maybe use the SNOMED hierarchy, right, which gives us some higher level concepts as parents of more specific concepts, or CCSR categories, which is put out by the AHRQ, a governmental organization that groups ICD-10 codes to be clinically relevant. So each of these domains has a number of reference value sets, we call them, that we can use, but oftentimes we need to create our own. And so for COVID, for example, when it's a new disease out there, there aren't going to be those value sets. And so we need to be able to react and continuously monitor the data to see what's needed based on the use cases we're going after.
Yeah, absolutely. Now, to this point, we have a question from Carl Johnson. He's asking, do you have any thoughts on how the US CDI efforts and standards for data sharing can or will address these standardization challenges?
Yeah, it's a great question. So the standards that have come out are a great step forward, and they are both more specified than standards that have been in the past. So for example, for certain fields in fire, it says you need to use one of these codes. And there are certain rules that have come out from CMS that say data needs to be coded in a certain way. But even US CDI, while US CDI defines the set of data that needs to be shared, it's in an abstract sense, right? So it'll say you need to share conditions, you need to share labs, and you need to share these fields on those. And for certain players in the system, it actually mandates that you use fire to represent those fields. Others, it's still flexible. But then how those fields are populated is still going to potentially vary by implementation. And so while it may be that we have to provide a condition code or a lab code, and it may be that we actually know the field that that's going to be in, which makes conversion less of a challenge, we still have to deal with standardization of those codes if there's not the reference code provided in the data set. And using reference codes has not been mandated across the board. So we're still going to be seeing this. And it's going to take time for adoption to happen. So it's going to take time before the data is cleaner. It will never be perfectly clean. So we will always need to do some cleanup depending on our use case. If it's in a population health use case, maybe we can be a lot more flexible. But if it's a use case where we're trending a lab over time for an individual patient, or it's a use case where we're trying to do a scientific study and we need a very defined endpoint for an FDA application, we're going to need to make sure that it is that much more robust.
Absolutely. Well, yeah, thank you. So yeah, so to summarize, it sounds like you're saying that first conversion, yes, we'll hopefully make it easier, but it's not perfect. That second step, we still have that same type of issue, unfortunately.
Yes.
Okay.
Yes. Yeah.
Cool.
Even in places where we receive data from a system which is adhering to the FHIR standard and is adhering to implementation guides that have been put out, we still need to make some decisions on what fields we use for what, and on standardizing and classifying data. Got it.
Okay. And so I guess, yeah, so it makes a lot more sense to me how this could be so tricky. I now understand that, okay, these files don't exactly communicate the best all the time. The mapping can be somewhat difficult. And even once you have all of our diagnostic codes, it doesn't always match exactly what your question is. Like for our case, I don't really care what the diagnosis is, that it's secondary to COVID, or I don't care that the primary or secondary diagnosis. I care that this person is infected with COVID. Right. And so
the more general category around
ex
the specific diagnosis codes that might be an ICD-10, for example.
exactly. I don't, it's not so important that this person has, wet macular degeneration, secondary diabetes. I care that they have a loss of vision. And so that's my group that I care about. So I guess there's one more step of kind of like, then you're saying like classifying them into these like categories then?
Exactly. So leveraging value sets
Okay.
to do the categorization. And sometimes that comes along with a data pipeline, a big system that an organization, whether it's a provider that is looking to do population health, or a payer doing care management, or a research organization might purchase a system that can actually kind of do this whole pipeline.
Mm-hmm.
And those often have value sets and other things built in, but they may not be as customizable as you'd like. And so a lot of times organizations kind of take a DIY approach, right?
Okay.
And do ad hoc building of this pipeline from conversion to standardization, classification on their own. And that might work for one particular project. But if you're doing this over multiple conditions with lots of projects over time, it is probably not something that is sustainable. And you're probably dedicating resources, oftentimes expensive data science resources, that end up then doing 90% of their time on data cleanup instead of focusing on doing the actual analysis and getting insights, right? So you've got this trade-off in kind of build versus buy of, do I do it myself? In which case I have total ability to customize, I have total visibility into my whole data pipeline, but I might not have the expertise to do it. I don't necessarily have the time or the resources to maintain it.
Yeah.
Or do I adopt a big system that might solve the problem end to end, but might be really expensive, might require an enterprise level kind of acquisition, right? Which is very different than me being able to make that decision, as well as it doesn't necessarily allow you to customize, configure, and have transparency into the pipeline. But what I'm really excited about these days is that I think that the build versus buy distinction is probably a false dichotomy at this point, because now we have APIs, called application programming interfaces. And this essentially allows functionality for things like conversion and standardization and classification to be offered in a very modular way, where I can just use that service, call it very easily, whether I'm calling it from an application or from an analysis or an analytical platform. And I can then see my data at every point in the data pipeline. So I can call and get this functionality, I can call and get this functionality, and I actually see it returned at each point in the pipeline. So APIs are a really fantastic development, which have been used very widely in most other industries for the past 20 years. Healthcare is a bit late to the table, but we're now seeing more and more APIs being published, and terminology services as well as other data enhancements are now available in this way.
I see. Yeah, that was one of those things that when we first talked about, I can't, the idea of building it yourself, and trying to do all of this all yourself with it, I thought, who actually does that? And I loved your insight. You're like, well, most people
do.
and then walking through it, I go, yeah, I see how that happens. And I can absolutely see how, if you're trying to go quickly, how you can miss the things that you don't see, right? Like there are going to be patients diagnosed with COVID that, you can sort through manually and say, okay, no, rule out, but I'm never going to catch the person that had it coded, so, COVID-19 or COV, 219 or something like that. I'm never going to see that. It's not going to pop up into my data set, where I can see that being the problem, is that you're missing people and you just have no idea if you go quickly.
So maybe it would help if I gave a real world example.
Yeah, I'd love to see it. Yeah.
Funny enough,
Whoa.
So let's take a look at this, and I'm going to show this through a what's called a Jupyter notebook. This is using a programming language called Python, and a Jupyter notebook is basically just an easy way to have little blocks of code that you can run one at a time to see how that code operates and see the results right there. So let's take a look at a sample of patients. In this case, we're just going to pull in 10 patients, and we're going to try to understand how many have a confirmed or suspected COVID diagnosis. And we'll do it by a bunch of different methods. So first, we'll take a look at it from just using an ICD-10 code. Then we'll look at it through string matching, and then we'll look at it using APIs. Okay, so here's the set of things we're going to do. We'll pull in some data. We're going to extract the conditions, and then we're going to standardize and classify. So first thing I'm going to do here is pull in from my local drive. I'm going to pull in a sample of CCDAs. And you'll note that I'm showing screenshots here. I typically give a demo like this live using a notebook, but we wanted to kind of take the variable out of here, but know that I just ran this and took screenshots as I went. So we've loaded in 10 files, okay? And we can see down here at the bottom, one of those CCDAs, it's an XML document, and it's got things like patient demographics, it's got things like medications, but you can see this is pretty hard for a human to parse. This is actually even hard for a computer to parse. We've got things like problems. Okay, so this is the structure of a CCDA document, which is pretty difficult to use for analytics. So what we're going to do is take those 10 CCDA documents, and we're going to hit an API to convert those documents from CCDA to FHIR R4. Okay.
Okay.
So
it's like that first step, you're converting it to a different type of file.
Yep. Okay. Took a few seconds. And now we can see, I'm showing here just one of the bundles, one of the resources in one of the bundles that was returned from that API. Okay. So for each of those CCDA documents, we now have a single FHIR bundle. I'm looking at FHIR bundle number 7. And I'm looking at the first condition in bundle 7's list of conditions. And we can see this is an injury of the right ankle. It's got a code here. It's actually also has some other codes associated with it. So what I can summarize here what I have. So across all 10 of those bundles, I now have 10 patient resources, 480 observations, 400 conditions, right? So that's been pulled out from all of those CCDA documents. What does that actually look like if I take an HL7 document? So first I'll load one in, and we can see here in the middle of the screen, this is what HL7 v2 looks like. Those of you who are familiar with it will know and love the pipe delimited format, which is very straining on the eyes. And we'll take that HL7 message, we will hit an API and convert the message to FHIR R4. So took a little over a second, we converted it. And so now we can see we have that HL7 message, and here it is as a FHIR bundle, okay? So now let's take a look at what we actually have in this data. So what I'm doing here is I'm extracting all of the condition.code, so all of the condition codings from all of this data that I now have in FHIR, okay? And I'm looking and I'm just pulling out what's the patient, so the patient ID, what's the code for that condition, and the display, the text that's actually accompanies that condition. And we can see there's a variety. So there's something here, U07.1 with an ICD-10 code. We've got stuff here that looks like a SNOMED code. We've got plenty of diagnoses here that are free text only. So in the code field, it just has a replication of what's in the text field.
Yeah.
So
real quick question from the audience is what systems API are you hitting to transform the data into FHIR R4?
So here we're actually using Care Evolution's Rosetta terminology API. It's part of our Orchestrate platform. There are others out there. I've seen some demonstrations from other companies like Rhapsody, I've looked at some from Amazon and Google, which work in pretty different ways, so aren't as modular as this is. I don't know the entire landscape, and our purpose here is not to kind of promote one platform, but this is using Care Evolution's API here.
Okay.
So now, if I were to try our first approach at identifying patients with confirmed COVID, let's take a look and use the U07.1 IC10 code. So all I'm doing here is a filter on that. And I can see that there's actually 2 patients, 979 and 946, who have the U07 code. Okay. Well, what if I try string matching? So what I'm going to do here is I'm looking for any text that says COVID, coronavirus, or SARS.
Okay.
Okay. So I apply the filter, and now I've got these patients, 979, 941, 948, right? Some of them have multiple conditions, and I can see there's a variety of stuff here. Looks great. 2019 novel coronavirus. Okay. Advice given about COVID-19 by telephone. I don't know that I'm going to consider that a confirmed diagnosis, right? Hypoxia, sure. Cough, COVID-19 test. I don't know. COVID-19 A/B testing, right? So if I'm only doing string matching in a very unsophisticated way, I quickly understand I need to be a lot more sophisticated. So let's see, this is identifying now 8 patients with COVID-related strings, which is probably too many, as we can see by eyeballing it. So let's now standardize these conditions, okay? So as an example, let's say I take DM2, right, free text, and I hit an API. This is a standardized condition API from Rosetta. What I get back is the SNOMED code for type 2 diabetes and the ICD-10 code for type 2 diabetes. I can do a similar thing with standardized medication. So let's say I have Caduet 520. I hit the API. I get back an RX norm coding here. So I see that this is amlodipine and atorvastatin combination. Okay. I could do the same thing with Pfizer COVID vaccine booster, right? And if I hit the API with that, it standardizes to the RX norm code for that specific Pfizer vaccine. So if I were now to apply this API, the standardized condition, to all of our free text, all of our codes and free text, all of our conditions that we have in our sample, I hit the API, and now here's what I get back. So here was what was in our sample, the patients with their codes and displays. And now on the right here, you can see I've got reference codes and reference displays from a particular reference system. So, clearly U07.1 is being mapped to, it's being identified that it is indeed an ICD-10 code. But we can also see that something like 2019 novel coronavirus is being mapped to the SNOMED code for suspected disease for SARS-CoV-2. Acute hypoxia COVID-19 is being mapped to the SNOMED code for ARDS with COVID-19. Antibody test is actually being mapped to suspected disease, right? And we can go down this list. We can see things like cough COVID-19 test also being mapped to suspected disease. We're even identifying exposures. So cough with exposure to COVID-19, there is an ICD, a SNOMED code for exposure due to SARS-CoV-2.
Got it.
So now we're getting close, right? We're using the API. We've very quickly been able to map these terms to reference terms in ICD-10 and SNOMED. But as you can see, some of these are what we probably consider confirmed COVID diagnosis, and there's more than one. Some of them are suspected, et cetera. So we could by hand kind of draw circles around them, but we can also use an API for that. So as an example, we've got a classify condition API. So let's say, remember up above, we mapped DM2 to the ICD-10 code for diabetes, which
so
is
we've done like the first 2 steps. Yeah. Okay.
Exactly.
Got it.
So if we hit the classify condition API with that ICD-10 code, we actually get back the CCSR categories. So we can see that at a higher level than specifically diabetes without complication, there's just diabetes generally, right?
Yeah.
And there's a number of other things that this provides. It tells you whether it's acute or chronic. That's another set of value sets that AHRQ puts out. It actually gives you the HCC category, which is what CMS uses for risk adjustment for Medicare payments. And it tells you whether it's a behavioral health or a substance-related condition, as well as whether it's a COVID-19 condition. So the one above is not. You can do the same thing for classified medication. So that caduate that we standardized above, if we hit classify that medication, now we see it's an anti-anginal agent, or more broadly, a cardiovascular agent. We can actually extract its exact strength from the RX norm code. And we're also seeing here, is it immunization? Is it COVID related? Likewise with labs, right? So let's say we have a hemoglobin A1C LOINC code 4548.4. We can see that there's actually hemoglobin A1C over hemoglobin total. So the ratio is a component of this particular code, but there's others. There's probably 5 or 6 other hemoglobin A1C ratios in LOINC. And so if I wanted to just look at hemoglobin A1C overall, and I didn't care about each specific LOINC code, I could use the LOINC component here to group them together, right? Similarly, I can see that it's a chemistry lab.
I see.
So what we'll do here at the end is now let's classify our whole sample. So we had all of our 10 patients converted, we pulled out the conditions, we standardized all of the source terms to reference terms in SNOMED and ICD-10. And now we want to say, show me the ones that are confirmed COVID and differentiate those from suspected and exposed. So we hit the classify condition API for every one of these codes. And now we can get back, you see I'm pulling out here the COVID classification, confirmed, suspected, exposed. And so now I can do a count, right? And so looking at these final numbers, I can say out of the 10 patients in the sample, using the APIs, I've identified 4 that have a confirmed COVID diagnosis, 3 that have a suspected COVID diagnosis, and that's compared to the 2 that had the actual ICD-10 code, and 8 that was too broad using our string matching. So overall, this is just a great way to be able to leverage this capability that has been put out by an organization specifically focused in solving this kind of problem. So now I can take this data and incorporate it into my analysis or pipeline or application.
Yeah, no, I love this, and I see it as like a your little dot phrases that you use in clinical work, but just kind of like this is something a lot of people are doing, and if a lot of people are doing similar things, like looking for everybody in their system with diabetes or COVID or something like that, I just it makes sense to me. It's your tool to do that.
We shouldn't all have to write like the list of 50 ways I can have acronyms for DM2 and all write the 50 for COVID, et cetera. Like that should be something that we solve 1, 2, 3, whatever times, but those that solve it share it, right? And then when those of us that then do analysis or are using these multiple data sources in applications or in research, can leverage those tools so that we can then focus on what's value added kind of at the end of that data pipeline. Yeah,
absolutely. I've got a couple of questions from the audience. The first one's from Amna. I apologize if I'm not pronouncing it perfectly. The question is, are you using a system to convert the FHIR R4 data into something that can be queried by NUPI?
So great question. So yes, I have kind of behind the scenes here a little Python library that understands FHIR, and I can extract things like condition code, and I put it into a NumPy data frame. And obviously is familiar with Python and Pandas. That's exactly what I'm doing. I've looked at a whole bunch of software development kits out there. There's a number, that have all of which have FHIR in the name, and I have found that none of them have unfortunately ever met all of my needs. Like they usually break at some point. They're usually too strict. on something, like when I try to import a Fire payload that I know is valid Fire, it chokes on it and says sorry. Or it hasn't implemented all of the resources, and so I try to send a medication resource to it, and it says, well, you can only send us conditions and encounters, right? So I've always found them wanting. So we developed in-house little software development kit that does that, and provide it along with our API. Got it.
Okay. And the other question, well, first off, they start out with thanks for the presentation. So thank you. That was very nice of you. But it's kind of general with, with these APIs is then how do you handle, PHI or protected health information? Are there any considerations?
Yeah, it's an important question. So first, all of Care Evolution has been in the healthcare space for a long time. And so all of these APIs are written with security and privacy that is follows the conventions that were required to be consistent with HIPAA. Yeah. For the particular APIs that I showed today, we actually don't store any data. So these are all what are called restless APIs or stateless APIs. So the data is sent in. We don't actually store stuff. It does the conversion in memory, sends the response back. We're not actually storing that data. I see. And so there's no PHI, even if there was PHI in the data that was sent in, it's not stored. And several of the APIs like standardize and classify, while it's possible that some diagnosis code could include some PHI, right? Sometimes the patient's name or a date might be actually appended with the diagnosis code. Typically, those are terms that don't include PHI, but regardless, this is a system that is adherent to the requirements of HIPAA and is also stateless, and so it is not actually storing the data.
Okay, excellent. And hopefully that answers your question. Now, another question that I have here is in regards to kind of like the performance. So like are APIs performant if we have lots of data, like if there's lots of data to clean up, and is there any batch functionality so we can throw lots of data at it once?
Yeah. So many APIs have batch functionality. And so that does allow you to reduce the number of times you're going back and forth over the network. You can send a bunch of data at once, get that network hit only once and on the way back. But you can also use, and what we've often done with larger implementations is we use orchestration. And so essentially we'll set up multiple threads, right? So we might take a bunch of data, break it up into pieces, send this bunch of pieces, in parallel, send this bunch of pieces, in parallel, send this bunch of pieces. And because this is all implemented in the cloud on a very elastic infrastructure, basically we get the same performance when we're hitting it with a huge amount of stuff as we do when we're hitting it with just a little bit. The individual operations, I mean, a convert operation, could have megabytes of data, right, in these big documents that we're converting. So sometimes those may take a second or two to come back, and when you're doing lots of those, that will add up. But orchestrating, multi-threading, the APIs themselves are quite performant.
Got it. Excellent. Another question we have is, do you handle non-textual information, things like videos, photos, MRIs, anything like that?
So within the APIs that I showed today, that wouldn't apply, other than sometimes Fire bundles may include diagnostic report resources that may have an embedded PDF or an embedded image or other type of digital resource. And those, when they're converted, are carried on, right? So they would be passed on. We're not doing any additional processing of that in this process, other than passing it back on. So it will be in the outbound bundle. But in terms of like putting in an image or a study for standardization and such, these APIs don't do that, but there are certainly other APIs out there. And I've seen some, for example, for categorization of images. I don't know specifically, but I would imagine that there are APIs even for things like reading X-ray right? And getting a response back, but that's not what we were addressing today.
Focusing. Yeah, absolutely. And yeah, so somewhat similarly as you're getting to that last bit, one of the questions we have is, can you talk to about how you see medically tuned LLMs fitting into your solution, and how solving many underlying data issues in healthcare? It feels, in the comments, it feels like LLMs could cut some of these steps out as long as it's done safely and accurately.
Yeah, it's a fantastic question on everyone's mind. If you're not thinking about this now, you should be.
Yeah.
So a few things. One is machine learning generally can absolutely be very useful in this natural language processing that we're doing here. And in fact, behind the scenes, we have some ML in the pipeline, along with a bunch of other explicit rules.
Yeah.
We've actually tested large language models out for doing some of what I showed today, like standardization and classification.
Yeah.
As an example, we gave something like DM2 without complications in as to ChatGPT, and we said, can you please standardize this to SNOMED? And it came back with this beautiful text around, no problem, happy to do it.
Yeah.
Here's your SNOMED code. It gave a SNOMED code. Here's the display for the SNOMED code. It was a great, fantastic match. So I was like super impressed.
Yeah.
I went and looked up the SNOMED code, and it does not exist.
No.
So it made up the SNOMED code.
Okay.
Right. So a big problem, you probably have heard of the hallucinations problem with LLMs generally, right? You can see it right there. Now, that doesn't mean that it can't be useful if tuned much more specifically. So if you had, and some of the large language models are now making themselves available to either be run locally or to have a particular instance that's then additionally trained on a particular set. And so maybe if you gave it, here is a list of valid SNOMED codes, and you taught it those, you say, you are only give me an answer within that list, it would probably do a lot better. And so I think we're, just at the very beginning of this, and I think it absolutely is going to change this space. That won't change, I think, the fact that APIs can be really useful here, because what I would imagine is, I don't think every company out there or organization that has this need is going to go find their own LLM and make it do this stuff. You're still going to want to hit some type of terminology standardization API, and you shouldn't necessarily care behind the scenes if it is using natural language processing or machine learning or an LLM, as long as you get back really good mappings, right, in that case. So I think it's going to make a big difference behind the scenes for this stuff, but I wouldn't imagine that most organizations that are doing their own analytics are going to want to explore LLMs, at least for those use cases on their own. I
see. Okay, excellent. And then I think we have time for just one more question. Kind of on our mind, and it's been talked about in C, as well as kind of like this idea of of TEFCA, and how do you think how will TEFCA and the QHINs change our need to clean data up? Do you think it's going to change a bunch, and won't they obviate any need for this at all? Yeah, it's a great question. So what TEFCA, which is the trusted framework being put out by the ONC, this is as a result also of the 2016 Cures Act. Some parts of TEFCA are being put out like this year and next year, with the establishment of 6 what are called qualified health information networks that are essentially going to be networks of networks. So right now, in order to get data, you typically need to know what specific FHIR server or what particular EMR are you pulling that data from. Whereas theoretically, once TEFCA is in place, you'll be able to hit one node and it'll query across all of those FHIR endpoints, all EMRs, and you can get data across the whole system. So that'll be fantastic. Yeah. What it does really is open up the pipeline, but that doesn't mean that the data is going to be necessarily that much cleaner. In fact, in some ways it may be dirtier, because now you're going to have lots more data and more diversity of data, and that means messy. Yeah. And so it will mean that there's going to be more and more FHIR,
So that is going to, over time, reduce our need to convert data, hopefully, more and more,
Yeah.
actually in one format.
Yeah.
It's never going to all be in one format, but it'll get better. Yes. In terms of standardization and classification, I don't see TEFCA changing the need for that at all. We're still going to have challenges there. And those challenges are really going to remain because very often the way we want to do standardization or classification is specific to particular use cases. And so we're still going to need to be able to configure and vary the way in which we're doing that mapping.
Well, excellent.
So TEFCA is going to bring bigger amount of data and even more opportunity to then clean it up to put it to use. Got it.
Well, excellent. I think that's about all the time we have today. Again, I wanted to thank Vi for giving us the opportunity to talk about this. And of course, I want to thank all the attendees, all of you being here, kind of listening. And I really hope that everybody here leaves here with a little bit of a, if not a new idea or something different, just to go, that was pretty cool. I hadn't thought of it that way. And hopefully it changes some of what you do. So thank you to everybody. And thank you.
Thank you to everyone that joined us today. Please visit our website at hlth.com to catch up on all Health Go Live webinars. And join us in Las Vegas, October 8th through 11th for Health 2023.